Hello friends, we are now going to continue our talk about exponential functions, and today we're going to focus on exponential growth. So you all know the routine, but before we get started, I have just a little meme humor. Take a look here, and if you think this is funny, then make sure you let us know. All right. So we've been talking about exponential functions, and we alluded to the ideas of exponential growth and decay. So today we're going to focus on the idea of exponential growth. All that means is that a quantity is increasing by a fixed percentage at regular intervals. So some examples might be cases of a disease are increasing by 15% each day. You might hear that a savings account balance with 5% interest compounded quarterly. That would be an example of exponential growth because we're increasing the amount with interest. Home values appreciate, so goes up in value by 2% each year. In each situation, the increase occurs in regular intervals by some percentage. These situations can be modeled with an exponential growth equation. Okay, so the exponential growth equation is y equals a times 1 plus r to the t power, where a is going to be our initial value, so a starting point. We think of that as the y-intercept in an exponential function. R is going to be that growth factor, 1 plus the rate. So I should have been more specific here. The rate itself is r, and when we do the 1 plus r, that makes our growth factor. Okay. So the growth rate is a percentage, usually expressed as a decimal, and the growth factor is when you do 1 plus that growth rate. Okay? And t, of course, is time. So what we're going to do is we're going to take this problem, we're going to model with an exponential function, and then we're going to answer some questions. A job has a starting salary of $40,000, that's our A. Each year you earn a 2% increase, so that means R is 0.02. Remember 2% as a decimal, you would move that decimal 2 places over, fill in the 0 if needed. So our equation will be y equals 40,000 times 1 plus 0.02 to the t power. Okay? So our initial value is 40,000. That's how much we're starting with. The rate of increase is 2%, which is 0.02. The growth factor is 1 plus 0.02, which is just 1.02. And how much will be made after 10 years? Well, we're just going to replace that t value in our equation with 10. And I'm going to round this just to the nearest whole dollar, just because usually when we deal with salaries, we deal with whole number salaries. Okay, so using the calculator, I get $48,760. So this is how much you would make if you were earning 2% each year for a raise. Okay? Now, obviously raises don't work like that in the real world. It's going to depend on what your company offers each year, but usually at least 2% is what you'll get unless we're in some sort of horrible economic downturn, possibly like what we are now. But anyway, I don't want to dwell on that right now. Okay, Sally's training for a 5K, which is about 3.1 miles. On day 1, she started by running 0.25 miles without stopping. Her goal is to increase her mileage without stopping by 10%, so R is 0.10, each day. Okay, our initial value is going to be the 0.25 miles. The rate of increase is 10%, which we express as 0.10. The growth factor is 1 plus 0.10, which is 1.10, or just 1.1. And will she be able to run a full 5K after 30 days? So let's model this stuff with an equation. So y equals, initial value goes first, 1.10. So we take our growth factor. Remember, our growth factor is 1 plus r, and we already saw what r was. So that's why I'm using 1.10 here. And our time t would be 30 days. So I'm just going to use my calculator. And the calculator says that Sally will be able to run 4.36 miles. And since that's greater than what a 5K run is, yes, she can run a 5K. In 30 days. Actually, it would be less than that, but we're not solving anything for a variable right now. Or at least not an unknown exponent. We'll get to that later. Okay. So I'm going to have us try a couple problems here. Both of these are growth things, so we're not going to worry about this concept of decay right now. But what I want you to do is take a look at the first equation here. I'll do the first one with you, and then the second one I want you to try on your own. So for this one, it says, well, we know this is definitely growth, so that question's kind of whatever. The initial value is whatever is not receiving the exponent. So in this case, it would be 3. Okay? The growth factor, so the growth factor, that's this term right here, the 1.8. The growth rate, remember 1 plus r equals the growth factor. Okay? So if I subtract 1 from both sides, I get r is 0.8. Okay? So we'd say the rate is 0.8, or as a percentage, it'd be 80%. So you'd move that decimal 2 places over. Put a 0 in. Okay, so I want you to pause the video here, try out example 2 in the same way that I did example 1, and then check your answer after you've had a chance to try it out. Okay, now you should see the correct answers here, so do a little self-check, see if you got them correct. It's kind of hard to tell, but that's a 0.04 here. See if you got them right. If not, then just kind of double check, make sure that you understand the equation, the formula. And if you're still struggling, make sure you talk to myself or Mr. Hu in office hours. Okay, so some applications would be dealing with compound interest. This is how loans are dealt with, or money you put into a savings account, the interest that's formed. Formula we use for compound interest is A equals P times the quantity 1 plus R over N to the N times T. So P is principal, that's the money you put up, or the money you invest, whatever, or borrow, whatever it is, it's the initial amount of money. Rate is a decimal, that would be our R value. Number of compounds, that N tells us how many times we're going to compound a year, and I'll explain that in more detail in a moment. And T is going to be time. Sorry about that. T is going to be time, specifically in years. If what you're given is months, you're going to divide by 12, okay? It's not often you'll see months, but it could happen. So some things that you may see with this, quarterly means 4 times a year, so that means N equals 4. So these are N values. Semi-annually means 2 times a year. Monthly would mean 12 times a year. And daily would be 365 times a year. If it happens just annually, it's just 1 time a year, in which case we wouldn't even need the N's. Okay, so suppose you take out a loan for $5,000, that's P, with an interest rate of 7%, so R is 0.07, compounded annually, so N is just 1. Okay? So what we're going to do now is we're going to find an equation that will tell us how much we pay. So A equals our principal times 1 plus R over N to the N times T. We don't know T right now. So this would be our equation, which when you simplify that, since we're dividing the 0.07 by 1, that's just 0.07. And when we add 1 to that, we just get this equation when simplified. So if our loan was for 3 years, how much will you pay and how much will each payment be? Okay, so we take our 5,000 times 1.07 to the third power. And that gives us, that's $6,125.22. That's total. If we take that and we divide by, not 12, sorry, there are 36 months. I'm going to divide that by 36 because 12 times 3 is 36. If I divide this by 36, I get $170.15. Okay, so a little budgeting advice for you. Let's try another one. So we invest $500 into an account that yields 4% interest. Sorry, this is R. Compounded quarterly, so N equals 4, and that's for 10 years. So how much will the account be valued at? So we're just going to plug these numbers in. Okay, so I just literally plugged in each number into the formula. If you need to pause this so that you can catch up, please do so. So I simplified what's in the parentheses. 0.04 divided by 4 is 0.01. 1.01 to the 40th. That's going to give me $744.43. Okay? All right. Last thing we need to talk about is continuous compound interest, and this occurs when interest is compounded continuously. So we learned about this number E last time, which was about 2.718. If interest is compounded continuously, what we do is we do 1 time, or y equals p. That 1 plus r over n, that part gets replaced by e to the r times t. Sometimes I'll call these PERT problems. So principal is still p, r is still your rate as a decimal, and t is still time in years. Okay, but this time we have e, which is that number. It's that special number. So if you borrow $12,000 with a continuous compound interest, so continuous means e, the rate is 5%, so 0.05. T is 6 years. Okay. So part A says how much money will you owe in total over the 6 years. So, whoops, we're not using P. We have an amount, 12,000 times e to the 0.05 times 6. Do you have an E button on your calculator? Calculator tells me it is $16,198.31. That's how much you'll owe over the 6 years. And if you want to figure out the monthly payment, well, 6 times 12 is 72. So we're going to just divide this 16,198.31. Divide that by 72 months, you'll make payments. And each payment will be $224.98. Okay, so that's how you would calculate that. All right, so I know there are a lot of formulas in this problem, or in this lesson, and so it's probably going to be helpful if you go back and rewatch it, or at least go back and make sure you copied down formulas correctly. You'll need those formulas so that you can complete the assignment, so please make sure that you do that. And remember, when you're doing problems, please make sure you round anything that deals with money to the nearest cent unless you are told otherwise. Nearest cent means 2 decimal places. Okay? All right, have a wonderful day.